It is essential that you understand Big O when you go into a technical interview, because this will absolutely come up. Understanding this will also make you a better coder. So what is it? So think of it like this. We have two sets of code. We have code 1 and we have code 2. How do we determine which one is better? Now, both of these are going to accomplish the same thing, but they're written differently. Is code 1 better? Maybe it is easier to read. Or is code 2 better? Well, maybe there are other things about that make code 2 better. Well, Big O is a way to mathematically figure out which of these two is better, which one runs more efficiently. So obviously we can't measure this with a scale, so I'm going to bring in a stopwatch to make the point. Let's say we run code 1, and when we run it, we start a stopwatch, and it runs for 15 seconds. Then we reset the stopwatch, and we run code 2, and code 2 runs a lot longer than 15 seconds. Well, obviously we want our code to run as quickly as possible, be as efficient as possible. So by this measure, code 1 is the better code. This is what is called time complexity. But we don't measure time complexity in time. We measure it in the number of operations. And the reason we do that is if you took the same code and we ran it on a faster computer, obviously it would complete in less time, but the number of operations would be the same. So either way, on the fast computer or the slow computer, the time complexity would be the same. The number of operations would be the same. Also with Big O, we measure what is called space complexity. And space complexity is the amount of memory that something uses. So let's say code 1, while it's very fast and runs in 15 seconds, or comparatively fast, maybe it uses a lot of memory. And then we reset all of this and we look at code 2, and while that runs a really long time, the full minute, maybe it uses less memory. And if this is what's most important to you, maybe code 2 is better now. We are going to look mostly at time complexity, but space complexity will come up in interviews. They'll ask you, okay, you wrote this code in such a way, maybe during a whiteboard session or something like that. And they say, great, you've optimized for time complexity, but what if we care about space complexity more? How would you write it then? You will have to understand both concepts. But what we will focus on mostly in this course will be time complexity.